Hey, what's up, everyone? I'm Reactor, and this is Quinn. Today's article comes from news.mit.edu, which is MIT, apparently. It's the news at MIT.
Nice.
And it's titled, Self-Healing Material Can Build Itself from Carbon in the Air. Taking a page from green plants, new polymer grows through a chemical reaction with carbon dioxide.
That's awesome.
A material designed by MIT chemical engineers can react with carbon dioxide from the air to grow, strengthen, and even repair itself. The polymer, which might someday be used as construction or repair materials or for protective coatings, continuously converts the greenhouse gas into carbon-based materials that reinforces itself. Huh. Okay.
That could come in handy in space, maybe if it worked in space, right?
I don't think it would work in space.
No?
I think it needs CO2. Right? It pulls carbon dioxide out of the air or something. But, I mean, they would be able to go out there with a tank and spray CO2 at it if it worked that well.
Right.
The current version of the new material is a synthetic gel-like substance that performs a chemical process similar to the way plants incorporate carbon dioxide from the air into their growing tissues. The material might, for example, be made into panels of lightweight matrix that could be shipped to a construction site where they would harden and solidify just from exposure to air and sunlight, thereby saving on the energy and cost of transportation.
All right.
The finding is described in a paper in the Journal of Advanced Materials by Professor Michael Strano, postdoc, and 8 others at MIT and at University of California, Riverside. This is a completely new concept in material science, says Strano, the carbon C-Dubs professor of chemical engineering. What we call carbon-fixing materials doesn't exist yet today, outside of the biological realm, he says, describing materials that can transform carbon dioxide in the ambient air into a solid, stable form using only the power of sunlight, just as plants do. Developing a synthetic material that not only avoids the use of fossil fuels for its creation, but actually consumes carbon dioxide from the air, has obvious benefits for the environment and climate, the researchers point out. Imagine a synthetic material that could grow like trees, taking the carbon from the carbon dioxide and incorporating it into the material's backbone, Strano says. So, okay, this is...
If the polymer doesn't hurt the environment, that's a pretty awesome thing that it can do that.
Yeah, I guess. I can't imagine how you build with it.
And what kind of weird shapes would be
Doesn't
created
concrete
with it?
work like that? Well, I mean, it doesn't build itself, but...
I mean, yeah.
They're talking about, like, shipping costs? Like... Oh, because it would build itself. You have some, and then it pulls out from the air and creates more.
Right.
So that would be shipping costs wise, yeah. The material the team used in these initial proof-of-concept experiments did make use of one biological component, chloroplasts, the light-harnessing components within plant cells, which the researchers obtained from spinach leaves. The chloroplasts are not alive, but catalyze the reaction of carbon dioxide to glucose. Isolated chloroplasts are quite unstable, meaning that they tend to stop functioning after a few hours when removed from the plant. In their paper, Strano and his coworkers demonstrate methods to significantly increase the catalytic lifetime of extracted chloroplasts. In ongoing and future work, the chloroplast is being replaced by catalysts that are non-biological in origin, Strano says. A lot of stupid science talk here. The material the researchers used, a gel matrix composed of polymer made from aminopropyl methacrylamide and...
Nice.
I can pronounce words, just not names.
Right.
And glucose, an enzyme called glucose oxidase, and the chloroplast becomes stronger as it incorporates the carbon. It is not yet strong enough to be used as a building material, though it might function as a crack filling or coating material, the researchers say.
Right.
So like, they build up, like, the article, like, oh, we got this new substance that's amazing, but it doesn't work like that.
It's an outside coating, which you know that if they start releasing this stuff at, like, the local hardware store place, people are going to use it for the wrong thing. They always do. It'll be like, please only use this to coat, your chair outside of your patio, and then people will be trying to, like, seal up wounds on their skin with it.
It's not like a seal. I think it's like a building material. If you spray your chairs,
people are still gonna use it for the wrong thing. You're like, oh, I can fix that
spray
dent
the
in my
deck down.
car.
I can make my deck bigger.
Yeah.
No, I don't think it works like that. The team has worked on methods to produce materials of this type by the ton and is now focusing on optimizing the material's properties. Well, you should have optimized it before you made a ton, right?
Right.
Yeah. Or maybe they haven't done that, but commercial applications such as self-healing coatings and crack filling are realizable in the near term, they say, whereas additional advances in backbone chemistry and material sciences are needed before construction materials and composites can be developed. Well, I mean, if you had some sort of mesh that you sprayed with the stuff,
Right.
it would probably be very strong.
Like the
and
mesh
build-
would hold it together, and then it would keep forming around it, and like, right,
Gives it like a backbone.
right.
Advances in backbone chemistry. Yeah, whatever. One key advantage of such materials is they would be self-repairing upon exposure to sunlight or some indoor lighting, Strano says. If the surface is scratched or cracked, the affected area grows to fill in the gaps and repair the damage without requiring any external action. That's kind of weird. When does it know? How does it know when to stop? What if it doesn't?
I'm just imagining like someone with a backpack, like shooting foam, like people do in like attics of houses, and they're just shooting this plant crap everywhere.
While there has been widespread effort to develop self-healing materials that could mimic this ability of biological organisms, the researchers say, they have all required an active outside input to function. Heating, UV light, mechanical stress, or chemical treatment were needed to activate the process. By contrast, these materials need nothing but ambient light, and they incorporate mass from carbon in the atmosphere, which is ubiquitous. The material starts out as a liquid, Quack says, adding, "It is exciting to watch it as it starts to grow and cluster into a solid form."
I'm going to be completely honest with you, Reactor. I want to see this happen at some point. I want to see the plant stuff.
I don't even understand what they're trying to explain.
I don't know what they're trying to code either, but it just sounds cool.
It still sounds hypothetical.
It does.
It sounds like, oh, we invented this amazing machine, but we still need to build it. What?
Yeah.
Like, that doesn't sound...
yeah. I get what you're
Right.
saying.
Material science has never produced anything like this, Strano says. Yeah, and they still haven't, have they? I mean, they're implying that it's not complete. These materials mimic some aspects of something living, even though it's not reproducing. Because the findings open up a wide array of possible follow-up research, the U.S. Department of Energy is sponsoring a new program directed by Strano to develop it further. And start building fighter jets out of it. Our work shows that carbon dioxide need not be purely a burden and a cost, Strano says. It is also an opportunity in this respect. There's carbon everywhere. We build the world with carbon. Humans are made of carbon. Oh God, so it's going to start sucking the carbon out of humans. Like if you touch it, it'll heal it'll take your, flesh and heal itself.
Wait. So you're talking about sucking the life out of one thing and then putting it into a device that shoots it into
that's what he's
another
saying.
thing?
I thought they were saying they take the carbon out of the air, but what they're saying is life, everything that's alive is made of carbon, and it can rebuild itself by taking their life force.
Right, like they're taking all the plant's life force to seal up these garages or whatever the hell they're using.
So you
it
could build
for.
a house with this, but all the plants around it would die if you scratch the surface because it needs to heal, and it would suck.
The real question is, what happens when somebody has like 4 backpacks worth of this stuff, and they're just like making cars and trucks in their garage? Like, yep, made a plant truck. Don't need you anymore, Ford and Chevy.
Get in an accident as long as there's
Made of
carbon
plants.
nearby.
Not even getting hurt.
Crash into a tree. If there's humans nearby, or plants, it'll suck the tree in and heal your car.
Plant cars could really cut down on accidents and everything
Plant
else.
cars?
Yeah.
Vegan cars?
Yeah.
Is that a
Animals
thing?
might try to eat those, but
Vegan cars.
that's the cost you're going to pay. It's a small cost.
Well, vegan just means it wasn't made with animals.
If it's vegan, animals could eat it.
No. It doesn't mean it's edible. It just means it wasn't made with animal parts.
Oh, I got you.
You could have vegan rope, I believe.
Yeah, I think you're right.
Yeah. Our work shows that carbon dioxide need not be purely a burden and a cost, Turner says. It is also an opportunity in this respect. There's carbon everywhere. I know I already read this, but we build the world with carbon. Humans are made of carbon. Making a material that can access the abundant carbon all around us is a significant opportunity for material science. In this way, our work is about making materials that are not just carbon neutral, but carbon negative. The research team included Juan Pablo. I'm not going to read a bunch of names. The work was supported by the U.S. Department of Energy. That's pretty amazing.
Yeah, carbon
they,
negative.
They hypothetically invented something that's not invented yet, and that's impressive. It's also impressive that I don't know.
It's just kind of, yeah, I mean, it sounds unbelievable.
And it's not even that exciting.
Plant cars and trucks are exciting, in my opinion. That obviously is what I'm about, is plant cars.
Wait a minute. I wonder if it can heal humans.
Right. Like I said, someone's going to try it.
Like you wipe it on your wound?
Like,
and
my
then it
leg's cut
closes up,
open.
like-
Spray some plants on it.
Okay. You have anything else you want to say, though?
Nah.
Yeah, that's it from me. Thanks for watching the video. If you liked it, leave a comment. Let us know what you thought. Like the video if you enjoyed it. And feel free to check out our Patreon link in the description. Everything you can do to help us is appreciated. But we'll see you in the next video.